Hello, today we're going to be graphing rational functions. So rational functions are ratios of two polynomials. So you're going to take one equation and divide it by another equation. Today we're going to be working with linear equations for p of x and q of x up here. So when we're looking at this, the basic rational function is going to vary inversely with x. That's this over here where you have k over x versus varying directly. Ooh, there we go. That's y equals k times x. And we will get into that a little bit more. That's a linear relationship versus an inverse relationship, y equals k over x. So the inverse relationship here of y and x is y equals 1 over x. What's going to happen here is you're going to end up with a graph that looks like this. Now, if you were to type this in on your calculator, 1 divided by x, you would see this. You would see a table of values. This is called a hyperbola. This graph here is going to have a bunch of different characteristics than things that we've seen them before, but it's applied a different way. So the first thing to note is you are going to have something called a vertical asymptote. So just like your log graphs, your vertical asymptotes are going to be x equals some number. In this case, it's going to be x equals 0. You can see that on your graph here. If you were to draw in a vertical line here, your graph gets close to that but does not touch this. Now, vertical asymptotes are going to come from your denominator set equal to 0 because those are our excluded values. When you think of when we were doing our simplifying from before, our excluded values came from the denominator because we cannot divide by 0, which means your vertical asymptotes are something that you will never cross. Okay, think of Gandalf there. You're never going to cross a vertical asymptote because you will never be able to have that value. You'd be dividing by 0, and it just does not work. So vertical asymptotes are never crossed. But on top of a vertical asymptote, you're also going to have a horizontal asymptote. For these ones, they're going to start off with y equals 0. And as you can see on this one, you can see this horizontal line here through 0, so y equals 0. Horizontal asymptotes are going to be a line that the graph approaches with the end behavior. So on the left of the graph and on the right of the graph, your graph is going to get closer and closer and closer to that line. You sometimes cross horizontal asymptotes depending on the rest of the function. It's mainly for your end behavior of the graph. It's where your graph is approaching. Your domain is going to be a little bit interesting. It is going to be based off of your vertical asymptotes because they are excluded from your domain. So for this one here, it's going to be negative infinity to 0 and then 0 to positive infinity. Your range is going to depend on your graph, but for these ones, the ones that we are doing that are just inverse variations, that asymptote is going to be taken out of your range. So it's going to be negative infinity to 0, union 0 to infinity, based off of your graph and your horizontal asymptote being at y equals 0. So let's go ahead and take a look at how we are going to end up graphing these. So the very first one is an inverse variation here. So you can see that it's like the 1 over x, it just has that negative 4, which means it's going to be stretched by 4 and reflected over the x-axis. Now your vertical asymptote is always going to come from your denominator set equal to 0. So in this case, it's going to be x equals 0. And we can go ahead and draw that in our graph. I do want to see your asymptotes for these ones. The horizontal asymptote for these ones are going to start at y equals 0 before moving them all around. So we're going to draw in a horizontal asymptote at y equals 0. So what we're going to do is we're going to go ahead and graph this. So you can pull up your graphing calculator and you can type in y equals negative 4 over x. You can even make a table of values so that you can see all of the values that you can plot. I want a couple of points in each section. So it was negative 2 comma 2, negative 1 comma 4, and over here you can graph a couple more to get that shape of your graph. Your domain for this one is going to be negative infinity to 0, and then 0 to positive infinity. It is based off of your vertical asymptotes and your excluded values. Your range is based off of whatever your graph looks like. So negative infinity to 0, and then 0 to positive infinity. For these ones we're doing today, it is strictly based off of horizontal asymptotes, but that will change when we start changing the graphs up. So we could really change any A value up top there, and you could get different stretches and reflections and compressions, but you're going to end up with the same asymptotes. What we're going to do now is we're going to start moving your graph around using A, H, and K for your inverse variation here. So the X minus H here is going to move your graph right H or left H if it was a plus sign. The plus K is the up and down. And the A is the stretch like we just saw for number 1. So because we're going to start moving left and right and up and down, our asymptotes are going to change slightly. When we move to the right H, that is going to change our vertical asymptote. So our vertical asymptote is going to be X equals H because it's coming from our excluded values of our denominator. The up and down is going to change your horizontal asymptote. It's going to be Y equals K because it's taking that 0 and is moving up and down. So looking at this one, our vertical asymptote is coming from the denominator set equal to 0, which in this case you can see is going to be X equals 1 or X equals H. Once you get that, you are going to go ahead and graph that vertical line. Your horizontal asymptote for this one is going to be Y equals K, so it's going to be Y equals 2. So we are going to go ahead and graph that horizontal asymptote there. I'm going to make this clearer so we can see it. So our graph should kind of fit inside of either one of those kind of quadrants that are set up there. So to figure out the rest of this, what we can do is we can go ahead and take our calculator and we can go ahead and graph this. So this is this function right here, 3x minus 1 plus 2. And I'm going to go ahead and I'm going to make a table of values here. So you can go ahead and hit second table so you can see all of those values there. And you can plot a bunch of those to get some nice and consistent points here. Once we've gotten a couple in each section, you can go ahead and draw your graph, showing that you are getting close to your asymptotes but not crossing them. So your domain here is going to be negative infinity to positive 1, and then 1 to positive infinity. It should match your asymptote. Your range here is negative infinity up to 2, and then 2 to positive infinity. Okay. So here's what we're going to do. I'd like you to go ahead and try 3. So pause the video, try it on your own, and then come back here and just double check your answer, see if everything lines up. Okay, let's go ahead and check this out. Domain negative infinity to 2 and 2 to infinity, matching your asymptote at x equals 2. Range negative infinity to 3 and 3 to infinity, matching your horizontal asymptote at y equals 3. And then you can see the sketch of the graph based off of your graphing calculator, typing it in and coming up with points. So these were all inverse variation and then taking that inverse variation and moving it all around. That is not the only type of rational function. We are also going to talk about other hyperbolas. These are going to be the ones that are basically one linear function divided by another linear function. So the thing with this is the vertical asymptote is going to be the exact same thing. You're going to set the denominator equal to 0. So this is, again, still all of your excluded values. But because this one is set up differently than the last one, your horizontal asymptote is going to be slightly different. So to look at this, notice that you have x to the first power divided by x to the first power, whereas in the last one you had x to the 0 power divided by x to the first power. This one had an asymptote at y equals 0. But when you have linear divided by a linear, your asymptote is going to be the ratio of A to C, the leading coefficients for your linear terms. So y equals A over C. So our example here, it would be y equals 3 over 1, and that would be y equals 3. Your vertical asymptote would come from the denominator set equal to 0, and then you would graph those asymptotes and then go ahead and plot all of your points and then go from there. So let's go ahead and try one of these. Again, it's slightly different here. I'm going to start off with the vertical asymptote because that's going to be similar to what we did from before. So it's the denominator set equal to 0. So 2x minus 4 equals 0 gives you a vertical asymptote at x equals 2. Your horizontal asymptote is going to be the ratio of the leading coefficients, and that's because these are both linear terms here. So it's going to be y equals 1 divided by 2. So y equals 1/2. From here, we're going to go ahead and generate our graphs using our calculators. So we're going to go ahead and type in x plus 1 divided by 2x minus 4. Sorry. Let's just go ahead and delete these. Okay. So this is our graph, and we can make a table of values here so that you have a little bit more accurate points to help you graph that shape. So for this one here, we're going to go ahead and graph some of those points. A few in each section are going to be good enough to get that shape. You can see our vertical asymptote is not crossed. The horizontal asymptote is defining the end behavior of the functions on the left and the right of our graph. Your domain is negative infinity to 2, and then 2 to positive infinity. And your range is negative infinity to 1/2, and then 1/2 to positive infinity. So we're going to do one more. We just have to pay attention to which format this is. So this is not the AHK format. This is one linear function divided by another linear function. So vertical asymptote, think about what it would be. Denominator set equal to 0, so x equals -1. Horizontal asymptote, think about what that would be. Ratio of the leading coefficients, so y equals 1/3. Our domain is negative infinity to -1, and then -1 to positive infinity. And for today, our range is going to be negative infinity to 1/3, and then 1/3 to positive infinity. We're going to graph this on our calculator and come up with some other points. And as x goes to positive infinity, you can see we're approaching 1/3 for our y values. Same on the left-hand side. So that's how we graph inverse variations and hyperbolas. And so the homework down below, I'm going to say, is completely optional. If you have ones that you think you need to try a couple of times, go ahead and do that, okay? So if there's something that you would have to second guess or think about twice, go ahead and do a couple of those. But this is purely just practice for you to see how it went for today. So I'm not going to check it at all, completely optional. If you were good with everything we did for today, you should be just fine. Thank you very much for listening, and let me know if you have any questions.